internet gateways. So what are route tables? I'm sure you would have gone through the material I had given yesterday and experimented with the route tables, adding routes, deleting routes, and understanding how routes actually work. Gave you a few examples yesterday. Route tables defines rules termed as routes, which determine where network traffic from the subnet would be routed to. Right? It's basically a destination based, right? I mean, that's where I said there are two things. One is destination and the other is target. Okay, it's a destination based. So when a route table is associated with the subnet, any traffic originating from subnet with a specific destination would be evaluated by the rules in the route table. And if there is a specific route in the route table, it will route it to that particular specific route. If you don't find a specific route, and if you don't find that route, then it will either not route it or it will route it to 0000/0. Okay, that's where it is. So you have to always remember that any 000/0 will be not specific route. It's a not explicitly mentioned route. Okay, and route table, there are main route table which is created in every VPC, which you cannot delete, but you can add more custom route tables to your VPC. Okay, and every route table that you create will have one default route called local. Okay, which is called local, where it allows the communication within the VPC to happen, right? For example, like we created a VPC of 10.0.0.0/16. So there will be a route called with destination as 10.0.0.0.0 and target as local, which means that any traffic originating within the VPC should be routed within the VPC. Okay, that's route tables. And internet gateways. What is an internet gateway? Internet gateway is like your internet gateway at home, right? So where you have a Wi-Fi device and router, or in an office, if office users need access to internet, they would have an internet gateway. Similarly, internet gateway is a gateway for allowing internet access to your EC2 instances or any resources in VPC. Okay, it's a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the internet. And so an internet gateway serves two purposes: to provide a target in your VPC route tables for internet routable traffic, and to perform network address translations for instances that have been assigned public IPv4 addresses. An internet gateway supports IPv4 and IPv6 traffic. It does not cause availability risks or bandwidth constraints on your network traffic. There is no additional charge for having an internet gateway in your account. Okay. So yeah, internet gateway is not charged. I mean, you can just create an internet gateway. You won't be charged for that. But the data that passes through the internet gateway is of course charged. Any outbound data transfer is always charged in AWS. Inbound is all free. Inbound data to VPC is free. Any outbound is charged. Like for example, you're downloading a lot of files, right? I mean, that will not be charged. But when you download, imagine you're also sending data outside when you download, because when you're downloading, say, a 1 GB file, you would actually send an acknowledgement back to the site from where you're downloading, right? So that is an outbound charge. Okay, so that's chargeable. Okay, so that's basically an internet gateway. And then we also looked at an example of routes, how default route and multiple routes work, right? And we also looked at, we created a VPC, subnets and everything. So now your default route of 10.0.0.0/16, which routes the traffic locally within the VPC. And if you need a internet access, you need to create an internet gateway, attach that internet gateway to your VPC. Okay. And then you have to add the specific route in the route table with 0000 with the target as internet gateway. So that way, any EC2 instance which has got this route added to it in its subnets route table will have access to internet through internet gateway. It actually goes like this. Yeah, it goes like this. The traffic goes like this. It goes to first internet gateway, and then from internet gateway, it goes to internet. That's how the traffic would flow. We are going to see that now. Okay, we're going to learn that right now, and let us do some workshops and experiments with that. Okay. All right. If you see here, yeah, we've done the same thing here, right? So where you have a VPC and you've got subnets. Okay, this is a subnet. Subnet one, which is 10.0.0.0/24, right? So now here in this case, the local, it has got a route table attached to it. The subnet has got a route table attached to it, right? In fact, you can attach a route table only to a subnet, not at a VPC level, okay? Because it is specific to each subnet. So you have 10.0.0.0/16, which is local, and then anything 0.0.0 has to go through the internet gateway. So in this case, the internet gateway is attached to your VPC, and then it goes through the internet gateway. Okay, so now let's go and learn something more, right? What is a public subnet and private subnet, right? This is again an important concept you all have to understand. So how many people are there? Around 70 odd people are there. Okay. Okay. I hope the session is being recorded. Okay. All right. So yeah. So now I gave an example of an office which has got an intercom connection, and there is a there is also an outbound phone calls that you can make to outside world. You can make phone calls internally within office. You can also make a phone call outside, right? So now look at it this way, correct? I mean, you've got an office, right? And you've got a reception, okay? And the reception would receive people and provide appointments for people to visit others, to visit any officials in the office or visit people who are working in the office. And also the reception would manage any flow into the office, right? Everybody has to pass through reception. Nobody can bypass reception and have a backdoor entry, correct? So, and similarly, any external calls that come, it first comes to the internal reception, correct? There'll be a telephone operator who will be sitting at the reception, and they would receive the calls. Like, let's look at the hotel, right? I mean, hotel would receive the call. The hotel receptionist or the front desk executives would receive the call, and then they would actually send it to respective rooms. So similarly here also, receptionist would send it to and transfer the call to respective people to whom the call is intended for. Similarly, look at it this way, right? I mean, where I have VPC. Okay, I'm just going to clone this page so that you guys understand. Okay. Okay, so now I've got a VPC. I've got two subnets, subnet 1 and subnet 2. And I provisioned an internet gateway and attached it to my VPC. Okay, it's at a VPC level. It is not at a subnet level. It is at a VPC level. Okay, I've provisioned a internet gateway, attached it to the VPC. So now, if, for example, these are my route tables. Okay, so this is my route table that belongs to subnet 1. Okay, so assume I don't have this route in the subnet 1, and I'll also create a route table for subnet 2. Route table for subnet 2, and that also has forwards the traffic internally, because it's again the VPC's range, right? So now say for example, there is a EC2 instance that I provision in subnet 2, and I provision one EC2 instance in subnet 1, and I have an IP address of subnet 1's VPC IP addresses. EC2 instance IP address is 10.0.1.5 is the IP address of my this EC2 instance. And 10.0.2.50.5, I'll make it 10, okay, or 12. Okay, 10.0.2.12 is the IP address of my EC2 instance, which is in subnet 2. You see the range, it is 10.0.10/24. So /24 would give how many IP addresses?
250.
256, exactly. 251. Yeah, 256. 5 you can
251.
reduce, and
Yes, sir.
251 will be the available range. Okay. So now in subnet 2, similarly, I have 10.0.20/24. So my IP address that I allocated to my EC2 instance is 10.0.2.12. This is 10.0.15. Okay. So now 10.0.15 would like to talk to 10.0.2.12. Okay. So now how will it talk? First, what it will do is it will look at the route table that is associated with this subnet. So which is the route table associated with that subnet? It is this route table.
Yes.
Yes. Okay.
Yes.
Let me just take this slightly up. I'll bring this down here. So the route table that is associated with my subnet 1 is this route table, and what is associated with my subnet 2 is this route table. Okay. Subnet 1 route table is this. Subnet 2 route table is this. These are the two route tables associated with each subnet. Okay. So now EC2 10.0.15 has to talk to 10.0.2.12. So how will it talk? So now let's look at it. So now 10.0.15, the traffic will initiate from EC2 instance with the destination as 10.0.2.12. Okay, so now what it will do is first it will go to the router, which is the route table here, right? Anywhere it has to first go to the router, correct? Even at your home, when you want to connect to say google.com, the request will first go to the router. Router will decide where to send that request to. Okay, so because those rules are defined in the router. So here also in this case, first the request will go to the router, which is the route table in this case. It will go here. It will look at a rule, the first rule. What is the rule? The rule says any traffic with the destination as 10.0.0./16. So now in this case, it will first look at the, okay, somebody is trying to draw on my board. Okay, so in this case, if you see 10.0, in this case, if you see the destination that is targeted for the traffic is 10.0.2.12. Is that 10.0.2.12 within this range?
Yes.
Okay, because
Locally, it will connect.
yeah, correct. And then so what it will do is it is going to send it to local within the VPC. So now what will happen is this is going to actually send it to the route table. It is going to send it to the subnet 2, which is 10.0.2.12 that is taken care by the VPC. So now first it will come here. Let me draw the path, how it will look like. First path would be this guy will send the traffic to route table. Route table, which rule? The first rule, which is there, right? Yeah, I'll change the color a bit. I'll probably give a red color. Yeah, I'll give this color. Okay, so it'll first come here because the destination says 10.0.2.12. Okay, because 10.0.1.5 has to talk to 10.0.2.12, so the destination would be 10.0.2.12, correct? So the packet will first come to the router. In router, it will look at which destination in the rule list matches this destination. So this destination matches that. So it will send it to local. So then what would happen is this would forward the traffic to. So from here, it would actually go to this instance. Okay. So this is how the traffic. Okay. And then the target is local, right? Go here. So similarly, let's assume the reverse way, right? Where I will just clone this. Let's assume the reverse way. In the reverse way, EC2 instance in subnet 2 would want to talk to EC2 in subnet 1. So in this case, the destination for this would be 10.0.1.5. Okay, so follow the same path, right? So where it would basically send the traffic to the route table here. And then what would happen is it will see that it is local. So then the local would simply forward the traffic to this guy. Okay, so this is how the communication between the subnets between the various different EC2 instances happen. So now this is not between the subnets, even within the subnet also. So this scenario is, I'll put it here, communication between an EC2 instance in one subnet to other subnet. Okay, that is the scenario here. Here, the same communication between reverse scenario. Okay, so let's also look at how the communication within the subnet would happen, right? Okay, so now let's communication EC2 between an EC2 instance in the same subnets. Same subnets between EC2 instances within the same subnet. So, okay. So in this case, let's assume this is all not there. Okay. Let me delete all of this. So now you have another EC2 instance in this subnet. EC2, and that IP address is 10.0.1.6. Okay, so now 10.0.1.5 wants to talk to 10.0.1.6. So how will the traffic flow? It will be the same route. Okay, it will first go here within the subnet. It will try to look in the routing table. First, it will go to router. So routing table, it will first go here. It will check whether is there a traffic available for with that matches this, and then the router will decide that okay, it has to be routed internally, and then it will find where is the destination. Okay, it will find where the destination is. So in this case, the destination is supposed to be 10.0.1.6. Correct, and then it will forward the traffic to that destination locally. Within the same subnet. Okay, that's why if you see, you won't be able to delete this default local route in the route table. You can try deleting it. You will never be able to delete it, because if AWS allows you to delete, then the communication within the subnet within the VPC will be blocked. You won't be able to communicate, and your EC2 instances that you provision will all become islands. No communication will be there. All communication will be cut. Okay, within your EC2 instances, it's like as good as a standalone computer, which with no network connectivity. Right? Imagine you are buying a new laptop or desktop at home, and you're not connecting it to network. So it will be like that. If you delete, if you are, if you don't have the local route available in the route table. Okay, so that's how it works. So now let's dig into a little more concepts of. So now this is how the routing works, right? So now let's assume, let's take the same scenario of communication between an EC2 instance and one subnet to another subnet, where I want my EC2 instance to also talk to internet. In this case, because I don't have a route that routes my traffic to internet, correct? Because I don't have a 0000. I assume I want my EC2 instance to talk to Google, right? Browse Google. I don't have a route in my route table that actually sends it to Google or sends it to an internet. Okay, in order to do that, what am I supposed to do? Okay, let me just clone this diagram. I will come here. I will put a, say that this is public subnet. Now I'll introduce a concept called public subnets. What is public subnets? Okay, so now what is public subnets? Let's dive deep into that. Okay, so now my requirement is very clear. I want my EC2 instance to talk to internet, because I want internet access on my EC2 instances, where the destination would be, what will be the destination?
Gateway.
Sorry?
Internet gateway.
0.0.0.0.
0.00.
/0.
So always destination is a IP address or a CIDR range. Okay, destination would be 0000. Okay, so now again, it's actually you don't know. I mean, it can be any IP address, right? We don't know whether the IP address is X, Y, Z, and A, or it is something else. We don't know what it is, right? So it can be any IP address. It can be anything at the end of the day, correct? So that's what happens, and destination is 0000/0, right? So now that is the reason why we need an internet gateway. You need some. Okay, let's assume at home also, right? A lot of us have a router plus a modem, correct? You also have a modem, right, which connects to the phone line, and there is also a router which acts as the local network, right? Your mobiles, laptops, desktops, everything gets connected to that router, and then in turn the router is connected to the modem, correct? So now here also it is the same concept. Okay, you have a router which is your route table within the subnet or within the VPC, but you need a modem, right, to connect to the internet. So the modem is nothing but your internet gateway, which provides internet access to devices that are connected to it, devices that have got routes established to the modem. Okay, look at it that way. Okay, so from that perspective, if I want my destination to be 0000, any internet, any public, anything other than the local, if I want to route it outside, anything other than specific, I don't know the IP address of the internet address that I'm browsing through. All I know is, I know whether it is aws.amazon.com, or whether it is google.com, or whether it is microsoft.com, or whether it is Flipkart or Amazon, Swiggy, Zomato, Uber. That's all I know. I don't know anything other than that. Okay, So for that, what you will have to do is you have to add one more route in the route table, which says to 0.0.0.0/0, which sends the traffic to internet gateway. Okay, so now which sends the traffic to internet gateway. So the moment you do that, you are basically making the subnet a public subnet. Okay, then the subnet becomes a public subnet because it has got a gateway attachment, it has got an internet gateway attachment, and your EC2 instances in the subnet will be able to talk to internet. It can go and browse internet websites, and it can basically talk to internet through the internet gateway. That's why it is called a public subnet, because it is actually in a public zone. It is not physically in a public zone, but it has got access to accessing public websites, and it can go to internet, and it can browse through internet, and it can resolve the 0.0.0.0 to internet gateway. Okay, so now let us look at how the destination would flow. So in this case, I want to browse google.com. Okay, what would google.com resolve to? Let's do an NS lookup. NS lookup google.com. NS lookup is a tool which allows you to give the IP address of a specific website, right? So it is 142.250.76.78. Okay, that is the IP address that I want to browse. So the destination would be so the destination would be 142.250.76 and 78. Okay, so now as usual, right? It doesn't change the path. As usual, it will come to the route table. In the route table, it will search, are there any specific routes available to match this IP address or not? Okay, so what are the entries that are there in the route table? There are two entries here. Let's assume this entry is not there. I'm just deleting this entry for a time being. Okay, there's only one entry. So now you are trying to browse google.com through this. So it will first go to the traffic, will go to the router. A router will look for a rule to match this IP address. Do you find one in the rule list?
No.
No, because
No,
No,
sir.
sir.
yeah, because this is a 10.0 range, whereas here it's 142.250 range, right? So what it will do is it will simply drop the packet. It won't, because it doesn't find the route. So what the router will do is router will take the packet, it will simply drop it. So you won't be able to access, you won't be able to browse. You will see a page not found error on your browser. Okay, so now in order to make that happen, what you need to do is you need to add this route saying 0.0.0.0/0, which sends the traffic to internet gateway. So now in this case, what will happen is you want to browse it. So it will first come to the route table. It will find that rule number 2 matches this, matches the destination what you have, right? Because 0.0.0.0 is anything which is not explicitly mentioned. Anything other than this, right? That's like the membership example I gave you yesterday. Those who have annual membership, go here. And anybody who doesn't have any membership, go here.
Okay.
Okay, so now it will go there, and then
Paper
it will send it to
డాడీని అడిగి చెప్తా కాల్ చేస్తున్నాను.
yeah, Z038, please go on mute.
Sorry,
Yeah.
sorry, sorry.
So no problem. Yeah, so then you have then it'll find the target as internet gateway, and then it will forward this traffic to internet gateway like this. It will send the traffic to internet gateway. And then you'll be able to browse the website. Okay, so it will come here. It will find the route in the route table. It will go to the target. The target will send it to the respective target, which is attached to the VPC. So now any route table or subnet, right? Now you're associating a route table, right, to a subnet. So any route table and any subnet which has got a route table which has a internet gateway attached to it with a rule is called a public subnet. Whereas this subnet, the subnet 2, you're not having a route table associated with it, right? So that is called a private subnet because it is only private to the VPC. It is not public. Whereas in this case, subnet 1 is basically has got a internet gateway route associated with it to its associated route table. So it is called a public subnet. Whereas a private subnet is something where you don't have any internet access. You don't have 0000 associated with it. So it is called a private subnet. Okay, so now in this case, it's very clear. Public subnet is subnet 1 is public subnet. Subnet 2 is private subnet. Okay. Subnet 1 is public subnet. Subnet 2 is private subnet because your subnet 1 has a internet gateway route associated with it, and your EC2 instances or any resources in your subnet 1 will be able to resolve an internet access. Okay, and secondly, what will also happen is, apart from this, right? I mean, because what qualifies a public subnet? One, you need a route to 0000 through an internet gateway. That is number one qualification for becoming a public subnet. So now, usually when you provision EC2 instances on a subnet, right? So now I've provisioned an EC2 instance here, right? In subnet 2, it will pick up one IP address from the pool of IP addresses that I have. So what is that IP address? 10.0.20/24, right? So it has just picked up 10.0.2.12 and it has assigned it to this EC2 instance. So now what is this IP address? This is a private IP address within the VPC. That's the private IP address. Like I asked you to do a IP config in all your laptops or desktops, right? To understand what is your private IP address. It will be some 192.168, 1.10 or 1.20. Something like that, in that range, 192.168 range. Okay. Now, the same thing applies to the public subnets as well. So now in the public subnets also, any EC2 instance you provision, there will be an IP address associated with it, which will be a private IP address, 10.0.1.5, which belongs to this. Okay. But at the same time, whenever a subnet is a public subnet where it has a 0.0.0/0 internet gateway attached to it, every EC2 instance in that will also get a public IP address, IPv4, right? Whatever is that 4.1 billion IP addresses that are there. 400 crores IP address that we saw the other day, right? IPv4 public IP addresses. So it will allocate one of those public IP addresses to the EC2 instance, which is there in the public subnet, so that traffic can come from outside also. It will allow the traffic to come from outside also. From somebody from outside world is coming, it will allow the traffic to come from outside. Okay, let me depict that. Okay, so now let me just remove all these crisscrossing lines. Also delete this. Okay, so now subnet 1 is public subnet because since it has an IGW route attached to its route table. That is the justification why subnet 1 is private subnet. Sorry, public subnet. Whereas private subnet because it does not have a IGW in its route table. So when we say IGW, which is the 0000 000/0 route attached to its route table, whereas it in private subnet it doesn't have. Okay. So now this is the private IP address, right? Equal to private IP. Similarly, here also it's a private IP. So now any public subnet, in this case, it's a public subnet, correct? I'm going to call it as public route table, which is okay. Let me present it a little different. I need to say that public this is private. Okay, this is a public subnet, this is a private subnet. Why it is public subnet? Because it has a IGW associated route. So now any EC2 instance that you provision in a public subnet will also get a public IP associated with it, some public IP, right, which starts with something. I'm just giving a random one, 76.6.
Sir, I have a doubt actually.
Yeah, please tell me.
You are putting a subnet, public subnet IGW as 000.0, right?
Yeah.
If you put that to any DNS address, it won't go. It won't get connected to the internet. Huh?
You mean instead of 00, right? No, you
Instead
because
of 00,
route tables, yeah, route
if you
tables
put some
does not accept a DNS. Route tables always accept only IP addresses.
like Google's DNS is 8.8.8, that becomes IP address only. No? Why can't we?
Yes, yes. You can put that. That's okay. You can put that. You can also do that. So, but it keeps changing, right? See that 8.8.8.8 is Google's DNS server. That is not the Google's IP address. But you don't have to send the traffic to the Google's DNS server, right? You have to send it to the actual Google's web server, which is serving the page google.com, correct?
Yes. Okay.
You can, if you know the IP address of any public, you can put that public IP address directly here, which will take the traffic through IGW. But on the public world, you don't address anything using the IP address, right? Rather, you don't interact with it through IP address, right? Like say, for example, I want to browse flipkart.com. I may not remember the IP address of flipkart.com, correct? I will only go hit flipkart.com. Internally, the DNS resolution happens. And then eventually the DNS resolution will return an IP address. And then the client will establish a connectivity with flipkart.com using that IP address, not the DNS. See, DNS is just a intermediary step. DNS resolution. You can put it. You're right. So if you know the IP address of any public, like say, for example, you're building your own website and you've got a static IP address, public IP address associated with your website, you can put that here in one of the route tables, right? And here I'll show you. In fact, why don't we try that? Let's try that out. Okay, we'll try that as part of our example. So what you can do is you can just simply, instead of the 000, you can put that IP address. So it will only go to that particular IP address. Okay, so it will only resolve that particular, it won't be able to browse other sites. So now here you want your EC2 instance to have unrestricted internet access, correct? So if you want your EC2 instance to have unrestricted internet access, then you have to leave it open. So 000 is like wide, anything, star, it's like star, asterisk. You have a wildcard asterisk, right? It's like the asterisk. It represents the asterisk basically. But if you restrict it, you will only be able to allow only those sites in the route table. And you won't be able to use DNS endpoint in the route table. It has to be only an IP address. And remember, Google's 8.8.8.8 is not its IP address. That is only the DNS server of Google. It's not the actual web server of Google. Okay, does that answer your question?
What I meant was basically, if we have a own website, we can put our IP address there so that we
You can put
connect it to. Yeah.
You can put it. Definitely, you can put it. Yeah, that is possible. So you don't have to really rely on 000. If you, instead of 000, you can actually put a, so let's assume this is your website's IP address. What you can do is you can just put it here, /32. You have to give /32 here, because /32 is, what is /32?
Only one IP.
Only one IP,
sir.
right? Correct. Right. So only one IP. So in this case, if my EC2 instance is trying to talk to, sorry, who brought up this point? Can you identify yourself?
038, sir.
Z038. Okay. So now Z038 has got a website that he has built, which is running on this public IP address on the internet, right? So in that case, you can put a rule in the route table saying that anything with the destination as 34.76.6.156, which is /32, push it to internet gateway. So it will simply take this and push it to internet gateway. So his EC2 instance will work only for this website. It won't work for any other websites. It won't be able to browse Google. It won't be able to browse Amazon.com or anything else. It will only work for his particular website, because it's only whitelisted. So it's like you're whitelisting it here, right? You're only whitelisting, you're only allowing a certain IP address to pass through the internet gateway. Now let's make this a little more interesting. Yeah.
Sir, in this case, this is the public subnet or private subnet?
This is a public subnet only. See, it is a public subnet only, but what will happen is it is a partial public subnet. It's not a full public subnet.
Yeah, we are allowing only one site.
Only that, right? And also in this case, what will happen is you will not get a public IP associated, public IP allocated to it. Okay. So now, in order for that to happen, you anyways need to have a root rule that says 0000/0 that goes to IGW. Okay, we can actually test this, and we'll do a small POC and we'll test this out. Okay, so unless and until you have this rule, you will not get a public IP allocated to your some 46.8 equal to public IP. That is a public IP associated with this. Okay. So now in this case, what will happen is you also have a rule that says 0000 has to go to IGW. Plus at the same time, your EC2 instance is trying to access one particular destination of 34.76.6.156, right? So now what will happen? It will first come, the traffic will come to the route table. It will look in the route table. What is the more specific IP address rule that is available here? This is the second is the one which is matching this, right? Which is more specific. So it will straight away take it and push it to IGW. Okay. In case you don't have this, then it will come here. It will push it to rule number 3, which is still an IGW. Okay. Let's try this out. It's a good experiment. Let's see whether it works or not. Okay. Yeah. In fact, but from a routing perspective, Z046, whatever you had brought up, is perfectly valid, because that's how routing works. Okay. And even tomorrow, when you want to implement a firewall, and when you want all traffic to go through the firewall, and when you want to restrict certain communication, you will follow these principles at the end of the day. Okay. So this is how it eventually works.
It's Z038, sir.
Sorry, Z038. Yeah, sorry. All right. So now you know what is the difference between a public subnet and private subnet. Okay. So now let's do one thing. Let's just do a small. Okay. So now you can also create like custom route tables, right? I mean, you have a default route table, the main route table. Now you want to actually have create public subnets, private subnets. You can't achieve it using one single route table, right? You need 2 route tables. Now let's assume this is your main route table. This can be your custom route table. You create a new route table, custom route table, which allows access within the VPC only for this local route. Whereas your main route table has got this IGW associated with it. Okay, so now that's when you would need to end up creating custom route tables, because one route table is not enough. Because if you have one route table attached to the VPC, all the subnets by default will be attached to that only that route table, and all the rules that are there in that route table will apply to all the subnets. Okay, let's assume there's only one route table that you have, and you have attached all the subnets to it. Then all the subnets will become your public subnets. You won't be able to create a private subnet there in all the subnets. So that's why you need multiple route tables, where you will be able to associate one or more subnets to that route table. So you have subnet and route table, right? So it's basically with subnets and route table, the relationship is many to one. Please get that understanding very clearly. Subnet 1, subnet 2, subnet 3, subnet 4. There are 4 subnets. And route table 1, route table 2. Okay. So it will be a many to one relationship. Many subnets can be associated to one route table. Sorry, 1 second. Just have to take this call. Yeah. So this is basically a many to one relationship. Many subnets one route table. So it's basically in a mathematical formula, it's n to 1 relationship. Okay. All right. You can also have individual route tables per subnet. That is also possible. You can just have, I have a subnet 5. It's and you have a route table 3. Okay, you can also do that. Just one subnet associated with the route table. Okay, all right. So let's get to, once again, I'll just stop my screen share. I'll just open my, yeah, okay, all right. Let's just do some exciting stuff. Okay, so now I have my, I hope all of you created your my VPC, which I asked you to do a couple of days back. Okay, so now let's review the my VPC. My VPC has got a CIDR range of 10.0.0.0/16. Okay, and how many subnets has it got? It has got about 3 subnets, subnet 1, 2, and 3. Okay, each deployed in different availability zone. Okay, so now let's look at internet gateway. Is there an internet gateway associated with my VPC? Yes, there is an internet gateway associated with my VPC. Okay, if you see VPC ID is my VPC, and I've got an internet gateway, which is my VPC internet gateway, and it is attached to it. And route tables, yeah, there is one main default route table that I have associated with my VPC or my subnet, basically at a VPC level. Okay, so now let's look at what are the subnets that are associated with this main route table. So now in this case, as I said, main route table is created with a default route of, initially this route was not there. Let me delete that route. I added this route later, so I'll delete that route. Initially, when my VPC gets created, this main route table also gets created. I will call it main RT, so that we can easily identify. Okay, this main route table also gets created by default, which has a default route that says any traffic originating for 10.0.0.0/16 will be routed internally as the local, as the target. Okay, now you won't be able to delete it. Try deleting it, you won't be able to delete it. Okay, so now what will happen is, so now let's do one thing. Let's try and implement this architecture. Which architecture? Let's implement this architecture. So where I want to create one public subnet. I want to create, I already have a private subnets. I want to create one public subnet now. I have 3 subnets. Okay, I want my public subnet to have a route to internet through internet gateway. Okay, so what we can do is, let us modify, or we can actually ignore the main route table also. You don't have to use the main route table. I can actually create a route table that says, just hit on create route table. I will say public route table, which VPC belongs to this VPC. I can add a tag which says name public route table. I'll be consistent. I'll just say RT, public RT. RT means route table. I've created a new route table called public route table. So it just created, and then it says whether it is the main route table or not. It is not the main route table, and you will have this default route any route table that you provision or create will have this default route. You won't be able to delete this route. So now what I want to do is I want to add this route to this 000 through internet gateway to this. Okay, so I'll just go here and then I'll add 0.0.0.0 to just select this drop down. You will find so many types of resources here, targets. Don't worry about others. For now, focus on internet gateway. Press internet gateway, click on internet gateway. You will get the list of internet gateways that are associated to your VPC. Click this, select this internet gateway and say save routes. So routes are successfully edited. Okay. So now, will this work? No, it won't work because there are no subnets associated with this route table. Okay. Now, if there are no subnets explicitly associated to any route table, they are implicitly associated to the main route table. So please remember that and understand that very, very clearly. Don't get confused. If you don't have explicit subnet associations with the route table, all those subnets are implicitly associated with your main route table. That is its default home. The default home for any subnet association is its main route table. Okay. So now what I want to do is I want to actually go to my public route table and then I'll associate my subnet 1, which is 10.01.0/24. That is my subnet 1, correct? Which is 10.01.24. So now click on edit subnet associations. So now these are all the subnets that I have. I want to use my subnet 1 on the public subnet as a public subnet. I'll select that and then I'll hit save. The moment you do that, what will happen is you will see that that subnet is associated with this route table, and you will see that in the explicit list out here. So if you see this, the subnet 1 10.0.10/24 has come up in the explicit list, whereas the rest of the subnets belong to your main route table, which is in the implicit list. Okay, and you see that 10.0.10/24 has gone away from this because it is explicitly associated with my public route table out here. Okay, which makes my subnet 1 as a public subnet. Subnet 1 has become a public subnet now. Now rest of the two subnets are private subnets because they belong to the main route table, and the main route table does not have a route to internet gateway, which is 0000. If you want, you can do it a little more granular. You can say private route table. Create one more route table called private route table, and then go to private route table. Don't add the 000 route here. Instead, go to subnet associations and bring your subnet 2 and subnet 3 into the private route table. So if you see, my private route table has got two subnets, which is subnet 2 and subnet 3. Main route table doesn't have any subnets. That's it. It's like it's useless right now, but I can't delete my main route table. It is useless. Okay. And your public route table has got one subnet, which is 10.0.1/0/24, which is subnet 1. So that's what has happened here. So rest of the two subnets are private, which will not get a public IP address, and your EC2 instances that you provision in your private subnets will not be able to access the internet. Okay. So now let's do some test here, whether our setup is working fine or not. So now you have configured the routing. Everything is working. Everything is set in place. You have segregated your public subnets. You have created your private subnets, and you have added a route to internet gateway through your main route table, which is subnet 1. So now let us go to EC2 and let us provision an EC2 instance. I'm going to my EC2. I'm going to say launch instance. I'm going to select Amazon Linux to AMI, which because Linux will come up very fast. Otherwise, I could have provisioned a Windows and showed you that in browser you hit google.com. But Linux also you can do it. You can do a curl google.com. So now here, if you see, I'm going to select the free tier. Okay, so now this page. Okay, in fact, last time I had asked you not to touch this page, correct? So now it's time to basically review this page. So now out here, there's something called number of instances. Leave it. You just want to provision only one instance. Purchasing option, you can just ignore it for now. I'll come back to that later. So now here, you have to select which VPC that it has to go in, right? So now I don't want to put it in my default VPC. I want to put it in my VPC because this is my VPC that I created. And then which subnet I want my EC2 instance to be provisioned. I've got 3 subnets, right? Subnet 1, Subnet 2, and Subnet 3. Which subnet I want my instance to be provisioned? I want my instance to be provisioned in the Subnet 1, which is the public subnet. So I will select public subnet, which is Subnet 1. Okay. So now there is one more thing that you need to do. What is that? Let me cancel this and go back. Okay. So now before that, I'll show you a difference. I will select my VPC here, and then I'll select the public subnet. But here, if you see, auto as an public IP is disabled right now. The reason why it is disabled is we have disabled it at the subnet. So for that, what you have to do is you have to go back to your VPC, go to your VPC, go to your subnets, select your subnet 1. In actions, there is an option called modify auto assign IP addresses. You have to go there and you can say that enable auto assign public IPv4 addresses. You have to check that. So now remember what I said was in a public subnet where you have a internet gateway associated route, when you provision an EC2 instance, it will automatically get a public IP address associated with it so that from outside world, people can come and speak to this EC2 instance or speak to your application. Or if you're hosting a web application on top of it, people will be able to access your web application coming from the outside world. But in order for that to happen, you have to make this setting. You have to enable this setting where you have to go to your subnet 1 and then checkbox this auto assign IPv4 and then hit on save. Okay, so the moment you say that, it'll actually have that setting enabled. Auto assign IPv4 is yes. So now you go back to your EC2 instance, EC2 dashboard, provision, launch a new EC2 instance, select the Linux 2 AMI, select the free tier T2.micro, select your VPC or my VPC, and select subnet 1. Now you see it is enabled. Use the subnet setting, which is enable here. So the moment auto assign public IP becomes enable, the EC2 instance that you're going to provision will have a public IP address associated with it. Okay. So now come down. You don't have to change anything else. Leave everything as it is. Okay. So now if you see, this is the network. This is the private network interface of that EC2 instance. So now primary IP is auto assigned. It will automatically go to the DHCP pool. It will get one IP address and it will associate it to it. Like in this case, we had assigned 10.0.1.5, right? So it will automatically associate that, assign that private IP, or you can also manually assign it here. If you want 10.0.1.5 to be assigned, you can say 10.0.1.5 to be assigned there. But I'm not going to do that. I'll just leave it like this. Add storage, leave this as it is. Security group. Okay, security groups again, just leave it as it is for now. Okay, you don't have to worry about it. Just leave it like this. I'll come to the security groups in the next subsequent classes. Review and launch and say launch. And then what I'm going to do is I'm just going to create a new key pair. I'm going to say that my key pair. I'm going to RPL AWS underscore my key pair. I'll just say download key pair. Okay, it is saved. Then I can just go ahead and say launch instance. Okay, so now if you see, if you go to launch instances, you will see that it is in the preparing stage. Okay, so now the interesting thing to note here is, okay, so now it got a private IP address, which is in this case like 20. Okay, 10.0.1.20 is the private IP address associated with the EC2 instance. Apart from that, it also got a public IPv4 address associated with it, 13.126.179.63. Is the public IP address associated with the EC2 instance that I provisioned in my public subnet. Okay, so now it is in a running state. So let's do one thing. Yeah, so let me just move that key to my keys folder. Sorry, what is the name? Keeper to. Okay, let me just move this and reshare my screen. / users. And remember, you have to do a chmod. Okay, why do you have to do chmod? Because your key will be wide open and you don't want your key to be left wide open. That's simple justification why you have to do a chmod.
Sir, even if we don't enable this auto IP option, we get a public IP, right?
You will get a public IP, but your instance will not be accessible from outside.
Okay. But when we created the
No,
first
so no,
EC2
hang on.
instance,
Sorry, your question is when you don't enable auto as an IP address, right? No, you won't get the IP address allocated to it.
but when we
Unless you
created
check
the
that.
first EC2, we didn't give any option there, but we got that public IP.
No,
Right?
that is default. By default it was enabled in the default VPC you're saying, right?
Oh,
Yeah,
okay. Okay.
in the default VPC it's enabled. You can go and check that. It will be enabled in that default VPC. You can check that. Okay, so now I've provisioned the EC2 instance and I have got the IP public IP address associated with this, because I won't be able to, from internet I won't be able to access this IP address, right? It won't allow me because it will not even know where that machine is. This is the only IP address which is resolvable from internet, correct? So now how do we connect to this? SSH -I. Yeah, and then EC2 user @ 13.126.179.63. You can try that. You can disable that, enable public IP address IPv4 auto assign. You will not get this public IPv4 associated with it. Because it will not be able to actually assign a public IP to that. Even though the routes are there, it will not be able to assign the public IP to that. Okay. Yeah. So it's able to connect to it. I'll say yes. It is. Yeah. You got it connected here. Okay. So now I'm able to connect to the EC2 instance. So now let's do something, right? Let's say I want to browse google.com. You can say curl google.com. Curl is nothing but it's like, okay, so you're able to actually access google.com, or you can say curl amazon aws.amazon.com. Yeah, so you'll be able to access. Okay, so now one more test that you can do is you can update the EC2 instance, right? So you can say sudo yum update, which will update all the software packages in the EC2 instance. Yeah, see, it is able to download. All these are coming from the public repos. Okay, all these are coming from the public repos. It's asking about 30 MB of data it needs to download. You say yes, it will download all of that. And it's going to basically update my EC2 instance. Okay, so now let it update this EC2 instance. Let's come back. I'm going to provision a similar EC2 instance in the private subnet now. Okay, I'll follow the same settings. what I'll do is I'll select my VPC. Instead of subnet 1, I'm going to select subnet 2, which is this subnet. Okay, subnet 2. I'm going to select that, but in the subnet 2, if you see, auto assign public IP is disabled. Okay, so let it be that way. And I'll say next, next, next. Okay, security groups. I'll just leave it like this for now. I'll just say launch. I will use the same keypad that I have. I'll say acknowledge. Okay, it is in a pending stage. Okay, so now if you see here, it has a private IP address which it got 10.02.204. 10.02, last octet is 204. That is a private IP address that it got. But did get a public IPv4 assigned to it? No. It's because number one, it is not a public subnet. It is not sitting in a public subnet. It's in a private subnet. And number two, it also doesn't have the assign auto assign IPv4 address. Okay, I'll just name it here. This is my public EC2. This is my private EC2. Okay, so now you may question, how do we connect to this then? Because I'm on public now, I'm on internet. How do I connect to this? Because there's no way I can connect to this, right? Because all I have is a private IP address only. I won't be able to connect to a private IP address from my internet. It has to be within that network, right? I'm not in that network currently. I'm only on a public internet right now. I'm on my home network. I'm not on that AWS network. Okay, so the way you can connect to that is where you need something called a bastion host or a jump server. I'll explain that later. For now, you don't have to worry about it. I'll come to that a bit in the subsequent classes. I'm going to do something naughty, which you're not supposed to do. I'm going to copy the PEM file that I created into my public EC2 instance, and from public EC2 instance, I'm going to connect to the private EC2 instance. What I'm going to do is, I'm first logging into, from internet, I'm going to log into my public EC2 instance, which is this 132, 120, 113, 126, 179, 63. From here, I'm going to log into this. You can do that, right? Because from here, if I want to log in, it will go to the route table. It will figure out that it has to be locally routed, and then it will send the traffic here, and then I'll be able to log into this. But in order to be able to log into this, I need the key to be present here. So I'm going to copy my key into this EC2 instance. Okay, so okay, you have to use SCP. How many of you know what an SCP is? It's a copy command. Okay, so SCP EC2 user @ 13.126.179.63. 13.126.179.63. Right? Okay. Next is /:home/EC2 user/ yeah. I'll give the file name. Okay, I have to give -i. Okay, SCP -i to user. Okay, actually it should be the other way around. SCP minus I this and then this to EC2 user and then delete the whole thing. Actually, it's worthwhile to kind of practice these commands. We don't use this on a day-to-day basis. I'm also struggling here. Okay, I've copied the key pair there. Now let me just go and SSH into that. Okay, that I brought the key pair here. So now from here I'll be able to SSH minus I RPL AWS. Okay, SSH minus I EC2 user at the rate. What is the IP address of my private instance? Is 10.0.2.204. Yeah, see, I'm able to connect to 10.0.2.204. But okay, let's try and access the internet from 10.0.2.204, right? I'm saying yum sudo, I'll say curl google.com. Does it work? No, it doesn't work because I don't have a route to internet from my private subnet. So it will time out. After some time, it will time out. From here, I'm trying to access Google. So what it does is it goes to the route table. Google's IP address is something that it is not able to resolve. And there's no route that says anything which is 000, take it to internet gateway. So it's not able to actually route the traffic through internet gateway. And then what it will do is it will eventually time out. I'll just hit. Similarly, let me open one more window and then I will connect to our 10.0.120, which is this instance 130 and 126. I've connected to that. I'll do the same here, curl google.com. See, it's able to immediately give me the response back. But whereas here curl to google.com is struggling. It's not able to actually give me the response. Okay, similarly, you do yum sudo yum update, it will get stuck because it's not able to talk to the public repos and get the updates from the public repository. It's not able to do update on the Linux server. So it will just get stuck. I have to just kill it. It will time out eventually. Whereas if I do it here, it can immediately say that no packages marked for update. Okay, that is the difference between what a public subnet and private subnet is. Private subnet and public subnet, and we created two EC2 instances. One EC2 instance is on public. The second EC2 instance is on private. The only difference is that in my VPC I have three subnets: subnet 1, subnet 2. Subnet 1 has got auto-assign IPv4 addresses. Route table, I've got 3 route tables. I'm ignoring my main route table. I've got my public route table, which has got subnet associated as subnet 1, route associated as local route, plus an internet routable route table here. And then private route table, I have no internet routable rule here. And my 2 other subnets, which is 2 and 3, are associated with my private route table. Exactly as we implemented in this architecture. Okay. So that's something that let's do that today. Let's practice that. So assignment is for today is learn these concepts, and I'm going to give you the
Excuse
PPT.
me, sir.
Yeah.
Sir, how can we connect to private network in Putty?
Okay, I just showed you, right, where you first copy the, you create a public EC2 instance. You can't connect directly. You have to have an intermediate
Yes, sir.
place. You have to first connect to your public EC2 instance. You have to copy the PEM file to the public EC2 instance. And from public EC2 instance, you have to again do an SSH. It has to be a 2 levels of SSH.
In Putty, sir.
Okay, Putty also same. First you connect using Putty to your
Yes,
public
sir.
EC2 instance. Okay.
Yes, sir.
Then you have to use something called WinSCP tool is there. Okay, like the
In
SCP that I
SCP.
just had.
Okay,
WinSCP.
sir.
You use that WinSCP to transfer that PEM file to your public EC2 instance.
Okay,
Okay.
sir.
Copy it to your EC2 home directory. And then from there, you can just go and access your SSH to the private EC2 instance. Okay, don't worry, you can try it out. I'll show you more tomorrow. I'm a little time pressed today. I have to jump into another meeting for now. Okay, so let's, okay, first is create 2 route tables. Okay, with one route table having 0000/02 internet gateway. Okay, then attach subnet 1 to public route table, subnet 2 to private route table. In subnet 1, change the auto assign public IPv4 to true. Okay, and then go to EC2 console, provision 2 EC2 instances, public EC2 instance with in the public subnet, private EC2 instance in the private subnet. Okay, so you can do this assignment for today. I'm going to send you this assignment.
Hello, sir.
Yeah.
Sir, I'm A04. Actually, ma'am provided us the credentials, but it is not logging in. It's showing the authentication is not correct.
Okay, you have to recheck your username and password because I'm able to access it. I mean, I got to know about it in the morning, but I'm able to access it. You have to just recheck your username and password properly so that it works.
Sir, I checked it multiple times, but it is not working.
Okay, what is your account ID?
Sir, I am
sorry, who's your mentor?
Arundhati, ma'am.
Who's A04? Okay. So Sister Arundhati, you can try logging in once using that URL and username and password, because I just tried. So what is the ID allocated to you? A04?
Sir, ID 2 minutes, sir. Sir, RPL user 2.
It's 2, right?
Yes.
Okay, it should work. I mean, I validated everything. I verified everything, before actually giving it to the people. I can check that.
Okay, sir.
Okay, you can go to your meeting room. You can go to your breakout room. Okay, I will just check that.
Okay, sir.
Okay, and I'll if I'm able to access it, I'm just going to let your mentor know, Arundhati ma'am, know about it, so that she can communicate it to you.
Okay, sir.
Okay, I've given the PPT and the assignment document to everybody in the chat, so please download it and try these exercises. And A04, I'm going to check that and come back. Okay.
Okay, sir.
Okay, all right. Thanks. I'm a little time pressed today. I'm not able to spend more time. I've got a call starting at 11 o'clock. So I have to just jump into that. But you guys continue to do this, continue to learn the steps that I've given in today's assignment. And, we can spend a little more time tomorrow to understand more on, I mean, if you have specific doubts, tomorrow